Hello everyone, I hope you're doing great. So today we're going to present to you our project that is about the start of a swimmer. As we know, it is a crucial aspect of a swimming race. It can be the difference between winning and losing, as a good start can give a swimmer a significant advantage at the beginning of the race. In this presentation, we will show you the different types of jumps and explain them using what we've learned so far in this course. Then we're going to show you the various factors that contribute to a good start for a swimmer and how swimmers can improve their starts to achieve their best performance in the water. Then we're going to show you what makes a bad start, and we will give a small conclusion about this whole presentation. So first of all, I'm going to show you the three different types of jumps, and you can tell us your opinion about the best jump that a swimmer can start with. So to answer this question, we need to know the purpose or the goal of the starting block. So in competitive swimming, the swimmer starts a race by standing on a slightly inclined starting pedestal or block for several reasons. For the first one is proper starting position. The inclination of the block allows the swimmers to lean forward and get a better push of the block at the start of the race. And the second one is fair start. The starting block ensures that all swimmers are at the same level and are able to push off with the same amount of force. Without the starting block, some swimmers might have an advantage by being able to push off from a higher or lower position. And finally, clean start. Without the starting block, swimmers might have difficulty finding a stable footing at the start of the race, which could lead to a false start or disqualifications. The starting block provides a secure and stable platform for the swimmers to push off from, ensuring a fair and clean start to the race. We showed you the purpose of the starting block for a swimmer. Now we will show you or explain to you the key factors for a good dive or a good start. So as we know, the angle of the block and the angle at which the diver travels towards the water are key factors in achieving the forward motion of the dive. Any swimmer of any level has heard the phrase dive out, not up. And also, we need to lose as little energy as possible due to friction.
So, we know that the equation of friction in any given fluid is 1/2 times A phi V squared CD, where A is where the surface is making contact with the fluid, phi the density of the fluid, V the speed of the object relative to the fluid, and finally CD the coefficient of the drag. We know that air's density equals to 1.2 grams per liter, while water's density equals to 1000 grams per liter, making water 830 times denser than air. Therefore, the key to minimize loss due to friction is minimizing time spent in water. And since the swimmer of the plot is just like a projectile, we need to maximize the range of the swimmer. We know that R as the range is v squared over g sine 2 theta. So to maximize r, sine 2 theta needs to be equal to 1 because v and g are constants in this comparison. Therefore, theta should be equal to 45 degrees. So now in the second part, let's see now what makes a bad dive for a swimmer. So the main keys that make a bad dive is first, air drag. Yes, drag can cause a bad start for a swimmer. Drag is the force of resistance that a swimmer experiences when moving through the water. It can be caused by various factors, such as the swimmer's body position, the shape and size of the swimmer's limbs, and the swimmer's level of fitness. A swimmer who experiences a lot of drag at the start of a race may have a slower start than their competitors. This is because the drag forces can slow the swimmer down and make it more difficult for them to generate power and speed. The second key is poor reaction time. Yes, poor reaction time can also contribute to a bad start for a swimmer. A swimmer who is slow to react to the starting signal can lose valuable time at the beginning of the race. This can be due to a variety of factors, including distractions, nervousness, or simply not being fully focused on the race. And finally, we have poor technique. A swimmer who does not properly execute the dive can lose momentum and time at the start of the race. This can include issues such as not fully extending the arms and legs during the dive, or not properly entering the water.
That's it. After all what's been said, you might think that the magical angle is 45 degrees, but it is not. Unlike here in the old Olympics, where swimmers try to maximize the distance, here we also need to minimize the entry area. That is because collision with water is strong. So we choose a bigger angle. But too high of an angle will make us go deeper, making it harder to resurface and also exposing us to deep and high density water, increasing the drag. So we need to smooth out the entry. For this reason, the best entry will be between 45 and 60 degrees, somewhere in the range of 50 degrees. So the swimmer must aim for a start like this one.